Electronics and semiconductor manufacturing. Next, background of electronics. The roots of the electronics industry go back to the 1800s, when scientists experimented with gaseous discharge tube and discovered that electricity could pass through gas from one metal electrode to another. Subsequent experiments led to the discovery of the vacuum tubes, a tube with all the gases removed, through which electric current could flow. In 1904, a British scientist, John Ambrose Fleming, built the first commercial vacuum tube. It was used to detect radio signals. Lee De Forest, an American inventor, produced a triode or three-electrode tube, which was the first electronic amplifier. In the 1950s, the electronic industry expanded with the first commercial use of the transistor and the development of semiconductor diodes. The electronic industry expanded even further with the development of integrated circuits in the late 1950s. Integrated circuits are very small semiconductor chips that can do the work of thousands of individual electron devices such as transistor. Next. In the 21st century, the electronic manufacturing industry continued to face many challenges. One of these challenges was to become more green or energy conscious and environmentally friendly. Creating lead-free part has become important and manufacturers had to create new materials and processes to become lead-free. Next. Next is background of semiconductor. History of semiconductor can be traced back to the invention of the rectifier or AC to DC converter in 1874. Decades later, Bardeen and Bertin at Bell Laboratories in the US invented the point contact transistor in 1947, and Shockley invented the junction transistor in 1948. This heralded the arrival of the transistor era. The semiconductor industry grew rapidly following the invention of the transistor. In 1959, the bipolar integrated circuit was invented by Kilby of Texas Instruments and Noyce of Fairchild Semiconductor in the US. This invention had a major impact on the history of semiconductors, and it marked down the IC era. Being small in size and light in weight, the IC was widely used in a variety of electric appliances.
Electronics manufacturing process. The electronics industry produces consumer electronics, electrical components, and industrial electronics. It involves a series of steps during its manufacturing process. Among the electrical equipment frequently created by the electronic manufacturing industry include circuit boards, televisions, and portable electronics. The industry that manufactures electronics includes industrial electronics, networking, electronic components, telecommunications, and consumer electronics. Next. Electronics manufacturing process. Step 1. Bill of materials. First, let's understand about the bill of materials or BOM. It is one section of the product's technical documentation. It is a compiled information source with a list of every component needed to create one unit of a finished product. During this process, manufacturers determine their overall costs and the types of materials they need. Step 2. Designing after the bill of materials is complete. The next step includes designing. Moreover, it is necessary to develop a manufacturing and design blueprint. Note that it's also crucial to create multiple designs in case something goes wrong. Product requirements. The first step in the design phase is to determine the product requirements. This includes defining the target market, the intended use of the product, and the desired features and functions. Conceptual design. Once the product requirements have been established, the next step is to create a conceptual design. This involves developing the overall appearance and layout of the product and determining the placement and arrangement of components. Detailed design. After the conceptual design has been approved, the next step is to create a detailed design. This involves specifying the components, materials, and manufacturing processes required to produce the product. Design for manufacturability. During the detailed design phase, manufacturers also consider design for manufacturability principles. Step 3. Testing a device. Testing a device is tested after it is produced. It helps to ensure that it performs well in a range of circumstances before it is put into production. Testing methods. There are several testing methods that are commonly used in the electronics manufacturing process, including automated testing, manual testing, and functional testing. Step 4. Distribution. Once you've completed developing and testing it, then it's time to distribute it. Distribution methods. There are several methods for distributing electronics, including physical distribution, online distribution, and international distribution. Physical distribution involves delivering the product to the customer using traditional transportation methods such as truck or air delivery.
Semiconductor manufacturing process. First, cleaning the silicon wafers forming the base of the semiconductor are cleaned. Even slight contamination of a wafer will cause defects in the circuit. Therefore, chemical agents are used to remove all contamination from ultrafine particles to minute amounts of organic or metallic residues generated in the production process or unwanted natural oxide layers generated due to exposure to air. 2. Film deposition. Thin film layers of silicon oxide, aluminum, and other metals that will become the circuit materials are formed on the wafer. There are a variety of ways to form these thin films, including sputtering, in which a target material, such as aluminum or other metal, is bombarded with ions which knock off atoms and molecules that are then deposited on the wafer surface. Electrodeposition, which is used to form copper wire layers, copper interconnect, chemical vapor deposition or CVD, in which special gases are mixed to cause a chemical reaction that forms a vapor containing the desired material, and then molecules generated in the reaction are deposited onto the wafer surface to form a film, and thermal oxidation, in which the wafer is heated to form a silicon oxide film on the wafer surface. Post-deposition cleaning. Minute particles adhering to the wafer after the film deposition are removed using brushes or nanospray with deionized water or other physical cleaning methods. Fourth, resist coating. The wafer surface is coated with resist or photosensitive chemical, then the wafer is spun, causing a uniform layer of resistance to be formed on the wafer surface by centrifugal force. Fifth, exposure the wafer is exposed using short wavelength deep ultraviolet radiation projected through a mask on which the circuit pattern has been formed. Only the areas of the resist layers that are exposed to the light undergo a structural change, thereby transferring the pattern to the wafer. There are a variety of exposure units, including steppers, which expose several chips at a time, and scanners, which expose the wafer using a slit through which light is projected onto the wafer. 6. Development developer is sprayed onto the wafer, dissolving the area exposed to the light, revealing the thin film on the wafer surface. The remaining resist areas that are not exposed at this point become the mask for the next etching process, and that resist pattern becomes the pattern on the layer below. 7. Etching. In wet etching, the exposed thin film on the surface layer is dissolved using chemicals such as hydrofluoric acid or phosphoric acid and removed. This forms the pattern. There is also a dry etching method in which the wafer surface is bombarded with ionized atoms to remove the film layer. Next, number 8. Implantation of impurities. In order to give the silicon substrate semiconducting properties, impurities such as phosphor or boron ions are implanted in the wafers. 9. Activation heat. Processing is performed using flash lamps or laser radiation to activate the dope ions implanted in the wafer. Instantaneous activation is required to create the microtransistors on the substrate. Next, number 10. Resist stripping resist can be stripped off at a wet station, which uses chemicals that remove the resist, or by ashing, which remove the resist by inducing a chemical reaction using gases. The wafer is cleaned after the ashing. Last, number 11, assembly. The wafer is separated into individual chips or dicing. The chips are connected to a metal frame called a lead frame using metal wire or wire bonding, and then closed in epoxy resin material or packaging.
Equipment used: industrial storage tanks. As the name suggests, the storage tanks are the containers used to store bulk quantities of a product. An appropriate storage tank ensures that the contents stored in the tank maintain their integrity. These tanks are often constructed in accordance with rules and regulations defined for material storage across various industries. They are available in various shapes and sizes, which vary as per the usage. Many industries make use of stainless steel tanks to hold various corrosive substance because of its excellent anti-corrosive properties, relative ease of use, and flexibility. Next, centrifuge. It is a machine that consists of a container that is used to separate contents by density. This equipment is most often used to separate different liquids and solid particulates from liquids. Moreover, they are also used for other purposes than mechanical separation. It is a vital piece of manufacturing equipment. There are various types of centrifuge used by manufacturers around the world, and they include this automatic centrifuge, this nozzle centrifuge, basket bottom dump centrifuge, and etc. Next, industrial mixers. Mixing of ingredients is an integral part of several industry manufacturing operations. This tank is often accomplished using various types of mixers. This device help blend or emulsify the materials of different types or the same type. Some types of industrial mixers used are double arm mixers, double cone V mixers, drum trap, dr- drum tumbles, homogenizer mixers, planetary mixers, batch compounders, and etc. Next, electric generators. Investing in an electric generator will help to keep your business running in the event of a power cut. They are used in different situations when power sources are simply insufficient. Most of the industry heavily rely on the generators as it will help to back up important data or machines in case of power outage. Used air compressors. Air compressors are used to increase the pressure on a fluid, and it can transport the fluid through a pipe to get the job done right. Compressors are widely used in environments for a wider range of uses, such as gas stations offer compressed air to inflate vehicles' tires. Moreover, small desktop air compressors are also available with an airbrush. Next, material handling equipment. Various types of material handling equipment are extensively used across major packaging industries. Many manufactured products must be packed before they are delivered to the user. This process requires a sort of handling during the manufacturing process and makes packaging equipment machinery most significant for several companies. All the mentioned equipment are highly used in the manufacturing of the product. This equipment will help to get done your job efficiently and improve performance as well. All in all, industrial equipment and machinery are an essential part of the manufacturing industry.
General safety before working on any electronics. Consider following these basic safety precautions to help reduce any hazards. Remove any electronic equipment you're testing or working on from the power source. Never assume the power circuit is off. Test and test again with a voltmeter to confirm. Remove fuses and replace them only after the power to the circuit is disconnected. Do not connect power to a circuit until you're done working on it and then check the work. Always ensure that all electronics equipment is properly grounded. If it's damaged, replace it. For instance, replace cables instead of repairing with insulating pipe. Always use the right electronics repair and maintenance tool. Always return covers after removing them to reduce the risk of electric shock. Make sure your circuit is not overloaded. Always have safety equipment like fire extinguisher, a basic first aid kit, and a mobile phone nearby. Safety in the semiconductor industry. Semiconductors have become valuable in our increasingly tech-driven world, and in the industry to continues to grow. Semiconductor unit shipments are expected to exceed 1 trillion units by 2018, compared to about 700 billion units in 2010 and fewer than 400 billion units in 2000. As with any industry experiencing tremendous growth, there is a concern that the semiconductor industry maintains its safety standards and minimizes harm to the environment. In other words, the more semiconductors produced, the greater the need for vigorous safety and environmental management. At first glance, the semiconductor industry looks sterile. Between the clean rooms and personal protective equipment such as gloves, gowns, and respirators, conditions at chip making plants have been described as cleaner than average hospitals. While the protective suit worn by the workers in the semiconductor industry are designed to protect the integrity of the semiconductor and its components, they also protect workers from exposure to potential hazardous materials. Additional PPE such as hearing protection, gloves, and respirators should be chosen with consideration for the job task performed by the workers. For example, workers in the semiconductor industry need hand protection that allows for dexterity as well as protection from substances found in the parts that they are manufacturing. Workers who are near heat or open flame should wear fire retardant clothing. Eye protection is required for a number of job tasks and should meet the appropriate ANSI and OSHA standards. Electrostatic discharge can be extremely hazardous when working with semiconductors and related components. In an effort to combat this, the team with Precision Polymer Engineering has devised a dissipative elastomer which facilitates a slow, controlled release of any unwanted electrical charges. Limited environmental factors. Another environmental issue facing the semiconductor industry is old, unwanted, or unused equipment. Millions of devices, from computers to tablets to mobile phones, are sold in the United States each year, and eventually they all will be discarded. This can be put a strain on landfills. Even more concerning are the amounts of heavy metals, lead, and other potentially hazardous substances that are discarded, which could pose a threat to the environment. Despite the growing problem of electronic waste, sometimes referred to as e-waste, there are some efforts to divert this unwanted waste from our landfills. Similar to other types of waste diversion initiatives, many communities and companies are now offering e-waste recycling and disposal services. Here's the video about semiconductor manufacturing processes. That's all. Thank you for listening.